Green hydrogen has entered a phase that many emerging energy technologies eventually reach, but few prepare for. The optimism that once surrounded it has faded. Capital is no longer abundant. Project timelines are stretching, and scrutiny has replaced enthusiasm. This is not a collapse phase, but it is no longer a promise phase either. It is a stress phase where technologies are tested not by vision decks, but by grids, balance sheets, utilization curves, and real operating environments. In this environment, many actors step back. Some pause, some exit, and some continue building despite the pressure. One of those companies is Plug Power. The question is not whether Plug Power believes in hydrogen as an idea. The question is why it still believes hydrogen is necessary as a system, even as the economics remain difficult and the market narrative has turned cautious. Most hydrogen discussions begin in the wrong place. They begin with technology. Electrolyzer efficiency, fuel cell stacks, catalyst improvements, or round-trip efficiency dominate the conversation. These details matter, but they are not decisive. Hydrogen does not succeed or fail because of incremental gains at the component level. It succeeds or fails because of system alignment. Hydrogen only works when production, storage, transport, and demand are synchronized across time and scale. When that alignment fails, costs explode, utilization collapses, and projects stall. Plug Power's persistence can only be understood when hydrogen is viewed not as a technology competing for attention, but as infrastructure attempting to solve constraints that electricity alone cannot resolve. Hydrogen has not suddenly become difficult. It has always been difficult. It has always required heavy capital, long development timelines, specialized infrastructure, and coordinated demand. What has changed is not the physics, but the financial environment. During periods of cheap capital, long-dated infrastructure can survive as a narrative. During periods of constrained capital, that same infrastructure must justify itself as necessary. This is where many hydrogen projects falter. They were designed for a world of optimism, not one of scrutiny. Plug Power's strategy, however, was never built around short-term validation. It was built around long-cycle infrastructure logic, where early inefficiencies are tolerated in exchange for eventual system relevance. Plug Power is often categorized narrowly as a fuel cell company or an electrolyzer manufacturer. That framing misses the intent of its strategy. The company has positioned itself across the hydrogen value chain, from production through electrolyzers, to liquefaction and storage, to distribution, and finally to end use through fuel cells. This vertical integration is not about capturing every margin. It is about reducing exposure to the most dangerous variable in hydrogen economics, which is utilization mismatch. When hydrogen production scales faster than demand, prices collapse. When demand materializes without infrastructure, projects fail. Vertical integration is an attempt to manage this mismatch internally, rather than leaving it entirely to market timing. Hydrogen is frequently portrayed as a competitor to batteries, but this framing obscures more than it clarifies. Batteries dominate where they should. Short-duration storage, passenger vehicles, distributed systems, and fast-response grid services are all areas where batteries are efficient, scalable, and economically compelling. Hydrogen does not replace batteries in these domains. Hydrogen becomes relevant where batteries begin to struggle structurally. Long-duration storage beyond several hours, seasonal energy balancing, industrial heat requirements, chemical feedstocks, heavy transport, and environments where weight or refueling time is critical, all fall outside the optimal range of batteries. These are not marginal use cases. They are the parts of the energy system that electrification alone does not easily reach. As electrification expands, these gaps do not shrink. They grow. More renewable generation increases intermittency challenges. More electric vehicles increase grid load concentration. More data centers increase demand for uninterrupted power. Hydrogen enters the conversation not because it is elegant, but because it can operate where electrons encounter friction. Plug Power's belief in hydrogen is rooted in this system's reality, rather than in a belief that hydrogen must dominate. Hydrogen does not need to win everywhere, it only needs to remain viable where alternatives face structural limits. One of the least discussed but most decisive factors in hydrogen viability is utilization. Nameplate capacity is misleading. Electrolyzers rated at hundreds of megawatts look impressive, but if they operate at low capacity factors, unit costs become untenable. Fuel cells that sit idle most of the time do not generate value. Hydrogen economics collapse quickly when assets are underused. Plug Power's early focus on logistics, material handling, and industrial fleets reflects an understanding of this risk. These environments offer predictable high-duty cycle operation. Forklifts, warehouse vehicles, and industrial equipment refuel frequently, operate continuously, and place a premium on uptime. In these settings, hydrogen does not need to be the cheapest option. It needs to be reliable, fast to refuel, and operationally competitive. Material handling is not a glamorous market, but it is a revealing one. Warehouses do not care about narratives, they care about throughput. Hydrogen fuel cells gained traction in this space because they reduced downtime and simplified operations compared to battery swapping. This is a critical insight. Hydrogen does not need to outperform batteries everywhere. It needs to outperform them where operational constraints matter more than theoretical efficiency. Plug Power's expansion into backup power, logistics hubs, and industrial environments follows the same logic. These are places where energy reliability is valued more than marginal cost savings. Electrolyzers, despite receiving the most attention, are not the core challenge in hydrogen deployment. The underlying technology is mature enough to function. The real challenge lies in integration. Grid access, renewable intermittency, water availability, balance of plant reliability, permitting timelines, and off-take agreements determine outcomes far more than stack efficiency. Many hydrogen projects fail, not because electrolyzers underperform, but because systems surrounding them do not align. Plug Power's large-scale deployments are less about proving technology and more about testing system execution under real constraints. This is where hydrogen moves from concept to infrastructure. Policy incentives play a role in this transition, but they are often misunderstood. Government support does not eliminate hydrogen's challenges. It compresses timelines. It allows infrastructure to be built before perfect markets exist. It accelerates learning curves and enables early deployments that would otherwise be financially impossible. Plug Power's strategy implicitly assumes that policy support is temporary. The goal is not to depend on subsidies indefinitely, but to use them as a bridge towards scale. Infrastructure has always required this kind of support during early phases. From railways to electricity to natural gas pipelines, hydrogen is no different. Financial volatility is often interpreted as evidence of strategic failure, but this interpretation lacks historical context. Every major energy system experienced long periods where capital intensity preceded stable returns. Oil and gas required decades of infrastructure build-out. Nuclear required state backing. Solar and wind required feed-in tariffs and long-term contracts. Batteries required sustained R&D and manufacturing scale before costs fell. Hydrogen is currently in this same phase. Short-term financial performance is not the primary indicator of long-term system relevance. The more important question is whether hydrogen addresses constraints that cannot be solved otherwise. Hydrogen's role in long-duration storage illustrates this point clearly. Batteries are excellent for short-term balancing, but their economics degrade as storage duration increases. Storing energy for days or weeks using batteries becomes prohibitively expensive. Hydrogen allows energy to be stored in molecular form, decoupling generation from use across longer timeframes. This capability becomes increasingly valuable as renewable penetration rises. Plug Power's belief in hydrogen reflects an expectation that these storage needs will become more acute, not less, as grids evolve. Industrial decarbonization presents a similar challenge. Many industrial processes require high-temperature heat or chemical inputs that electricity alone cannot easily provide. Steelmaking, ammonia production, and certain chemical processes rely on molecular energy. Hydrogen fits these requirements directly. While electrification can reduce emissions in many areas, it does not eliminate the need for molecules. Hydrogen occupies this molecular niche. Plug Power's strategy aligns with this reality rather than attempting to force hydrogen into inappropriate applications. It is important to recognize that persistence does not guarantee success. Plug Power may still face financial restructuring, competitive pressure, or strategic setbacks. Not every early infrastructure builder survives. History is full of examples where early entrants paved the way for others. The significance of Plug Power's continued investment lies less in its individual fate and more in what it signals about hydrogen's position in the energy system. Hydrogen is no longer being treated as an experiment. It is being tested as infrastructure. At Renee Energy, technologies are evaluated under stress rather than optimism. The question is always the same: if subsidies decline, if utilization falls short of projections, and if capital becomes expensive, what survives? Hydrogen survives only where it solves unavoidable constraints. Plug Power's ecosystem approach represents an attempt to operate within those survivable zones. It focuses on anchored demand, shared infrastructure, and applications where operational value outweighs cost uncertainty. The broader hydrogen landscape is undergoing a filtering process. Early enthusiasm attracted a wide range of projects, many of which lacked alignment between production and demand. As capital tightens, only projects with credible system integration will proceed. This is not a sign that hydrogen is failing. It is a sign that hydrogen is maturing. Selection pressure is a necessary phase in the evolution of infrastructure technologies. It removes fragile models and forces discipline. Hydrogen will not dominate the energy system. It will not replace electricity, and it will not displace batteries where batteries work well. Hydrogen's role is narrower and more specific. It fills gaps where electrification encounters structural limits. Plug Power's belief in hydrogen reflects an understanding of this role rather than an expectation of universal adoption. This distinction matters. Technologies that attempt to be everything often become nothing. Technologies that focus on irreducible constraints tend to persist. The energy transition is not a race toward a single solution. It is an exercise in system assembly. Solar, wind, batteries, grids, demand response, nuclear, and hydrogen all play different roles. Hydrogen's role is not glamorous, but it is necessary. It absorbs excess energy, transports energy where electrons cannot, and enables industrial processes that electricity alone cannot decarbonize. Plug Power's continued investment is a bet that these functions will remain essential as the system evolves. Ultimately, Plug Power still believes in green hydrogen because the problem hydrogen solves is not going away. Grid congestion will increase. Renewable intermittency will intensify. Industrial decarbonization will require molecules. Long-duration storage will remain unsolved by batteries alone. Hydrogen does not need to be cheap everywhere. It needs to be viable where alternatives fail. That is the threshold for infrastructure relevance. Understanding green hydrogen requires separating hype from survivability. It requires asking where systems break under stress and which technologies can operate in those conditions. If you want to explore green hydrogen through this lens, focusing on utilization, cost thresholds, infrastructure friction, and execution risk, H2 Hub by Renee Energy provides that perspective. The link is provided in the YouTube description below.